Today we'll be looking at triggers. Triggers are new to CockroachDB and they'll be introduced in version 24.3. They allow you to react to things happening in your database from within your database. For example, I was building out a demo of vectors, and to build the vector, I was using CDC to publish a message to Kafka, route the event to an application that normalized the data into a vector for me before pumping that data back into CockroachDB. I simplified that down over the course of a few iterations, but realized quite quickly that with a new trigger support, I would be able to do this from within the database itself. And these actions might be inserts, updates, deletes, or truncates, and you might want to respond to them either before they happen or after they've occurred. This demo will give you a feel for triggers in CockroachDB. I won't create every kind of trigger imaginable, but there are more features available than the ones I'm demoing today. I'm running CockroachDB from source because this functionality is quite new. So whenever you see Cockroach Dev on my command line, I'm simply referring to an early version of CockroachDB that will be available to you very soon. I'll spin up a cluster using Cockroach Demo, and I'll create some tables. I'll have a customer table, a product table, an orders table, an order items table, and a stock table. In this demo, I'll be creating customers who make purchases which affect the overall inventory of stock. I'll create some example customers and products, and for each of those products, I'll give them a quantity of 1,000. Next, I'll create a function. This will be invoked from our trigger after I insert new order items. Essentially, an order comes in with order items, and for each of those order items, I decrement the amount of stock based on the quantity of that product in the order. And that can be seen from the query. I update the stock table and I decrement the quantity on hand based on the existing quantity minus the quantity of the order item where the product matches. And with this query, I create the trigger. It's an after insert, and for each of the rows that it finds, it will execute the function that we just created. Let's have a look at the stock table before we make any changes. And as you can see, they're still set to their original value of 1,000. I'll create an order. This doesn't have any order items. So if we look at the stock table, that's still showing the original values. But now if I insert some order items for that order, for this product, I have a quantity of 1. And for this product, I have a quantity of 3. In the background, that insert has triggered the execution of my function, such that if I look at the stock table again, this product has been decremented, leaving us with a quantity on hand of 999, while this product that had a quantity of 3 in the order now has a quantity on hand of 997. This is a great way to maintain consistency of data across tables. Previously, I would have had to make a number of requests, possibly using something like a common table expression, or perhaps just wrapping the whole thing in a transaction to achieve the same result. That's now a concern that my application layer doesn't have to deal with. That was an after insert. Now I'll show you a before insert trigger, and I'm going to create a slightly different scenario. With these statements, I create 2 enum types, one for action, which is either buy or sell. This is a very contrived trading example, and another enum representing units, which can either be ounces, tons, or kilograms. Again, very contrived. There's no relationship to counterparties or securities or anything like that. I've kept it as basic as I can. But there's a nullable column called vec, which is a vector with 7 dimensions. I don't want to have to populate that from the application, so I'll use triggers to populate that column for me before I make the insert. This function is a bit more involved than the previous function, but all it does is build up an array of floating points and sets the vec column of the newly inserted row to be its concatenated result. Whenever I see an action of buy, I use the value 0, otherwise I use 1 for sell. For units, I create a one-hot encoding vector such that whenever I see ounces, I return the array 001, kilograms 010, or tons 100. And that will get bolted on to the end of the action dimension. Next, the normalized quantity, which again is very contrived. It calculates the quantity based on its position between a minimum and maximum value, the minimum being 1, the maximum being 1,000. This might want to be a call to another function, but currently I'm just using an arbitrary number. Same for price per unit, and again, you'd want to tie this to the unit somehow, because I'm just using a minimum of 1 and a maximum of 1,000, and the normalized value for timestamp, which is the position between midnight and 11 o'clock in the evening. I build up all of those results into a resulting vector and set the row's vec column to be that value. I'll create the trigger, which again is a before trigger this time, and I'll insert some data. I'll have a buy, sell, various unit types, quantities, and prices. And if I look at the table now, we've got 3 vectors populated by our trigger and our function. Triggers in CockroachDB once again bring our compatibility to Postgres much closer, making migrations easier, and generally expanding the feature set offered by CockroachDB. I've shown 2 scenarios today of where triggers might be useful in your workloads, but I'm sure there are many more. Give them a try for your use cases and let us know what you think.